Welcome to Pod 4 Journal Club. Today, we're diving into some super interesting research that tackles one of the biggest, and let's be honest, most annoying frustrations with AI.
You totally know the feeling. You spend ages teaching your AI assistant how to do something complicated, and it finally gets it right. But then the next time you or anyone else asks it to do the exact same thing, it's like it's back to square one, making all the same dumb mistakes. It's like all that knowledge you helped it gain just, poof, vanishes.
And this slide right here gets to the very heart of the problem. You see, AI agents today are basically isolated learners. Their skills are static, they don't really improve with experience, and any little breakthrough an agent has in one session is just lost. It never helps the system as a whole. So every single user is basically stuck solving the same problems over and over again.
So the real trick, the challenge we're facing, is how do we go from an AI that just learns in a single chat to one that learns from every single conversation across millions of users? Let's take a look at what that really means.
Okay, so here's the side-by-side. Right now, AI skills are pretty much set in stone and have to be manually updated. And all that knowledge, it's trapped in just one session. The goal, though, is to get to a place where skills actually evolve as people use them, where knowledge is shared among all users, and the whole system just keeps getting smarter and smarter, together.
So, how do we actually pull that off? Well, a group of researchers came up with a really clever idea. What if you built a team of AI mechanics that just worked in the background, fixing these problems for us?
And they called it SkillClaw. I gotta say, I love this little lobster mascot. It's the perfect visual. Think of SkillClaw as this team of AI mechanics just constantly working behind the scenes. They're watching how all the AIs are doing, spotting those repeating problems, and then upgrading the skills for everybody, all automatically.
Now, the real core of this system is something the paper calls an Agentic Evolver. This is basically an AI whose whole purpose in life is to watch us interact with other AIs, figure out why they're failing, and then literally rewrite their skills to be better. So, and this is the really cool part, it's an AI that teaches other AIs how to improve. That's a pretty mind-blowing concept, right?
That all sounds amazing in theory, but how does it work in practice? Okay, let's break down the actual process. The researchers came up with this simple but really powerful four-step loop. First, SkillClaw is just a vacuum for data. It collects all the interactions, good and bad, from every user. Then it sorts all that data by the specific skill that was being used. Step 3 is where the magic happens. The Agentic Evolver dives into that data, finds the patterns, and figures out how to upgrade the skill. And finally, Step 4, that new and improved skill gets sent right back out to all the users. It's a constant feedback loop. And this is exactly why grabbing data from everyone is so key. As the researchers put it, when lots of different people try to do the same thing in slightly different ways, you start to see where a skill's breaking points are. One person's experience might not be enough, but when you pull together thousands of interactions, you get this super clear picture of what's working and what isn't.
So does it actually work? Well, the researchers ran a 6-day experiment to put the system through its paces. Let's see what happened.
The results are, well, they're pretty darn impressive. This table shows the jump in performance from day 1, which was the baseline, all the way to day 6. I mean, you can see these really solid gains pretty much across the board, from search all the way to safety. The system was definitely learning.
But check this out. The most dramatic improvement was in creative synthesis. The performance pretty much doubled. That's a jump of almost 90%. What this suggests is that the system is getting really good at fixing those subtle, deep-down problems that often mess up more complex, creative work. That is a massive leap in just 6 days.
So here's the main takeaway. One person's struggle and eventual breakthrough can trigger an upgrade that automatically makes the tool better for everyone. And the best part? It all happens in the background. You don't have to do a single extra thing.
Let's look at a real example from the paper to make this concrete, analyzing Slack messages. Before SkillClaw, the AI agent had this very basic approach. It just tried to chug through every single message and kind of stumbled its way through any errors. But after SkillClaw worked its magic, the agent had a much smarter strategy. It learned to filter for the important messages first, and it knew how to deal with common errors before they even happened. So much more efficient.
And this just paints the perfect picture of the end result. The system took this messy, frustrating process and turned it into something smooth and reliable. That's what collective learning can do. It turns failure into function.
So what does all this mean for the future of AI? Let's zoom out a little bit and look at the bigger picture here.
What makes SkillClaw so different really boils down to 3 things. First, there's collective evolution.
It learns from all of us, so it benefits all of us. Second, it's fully automated. It just gets better on its own. And third, it has agentic adaptability. It's not using rigid old rules, it's using flexible AI reasoning to solve problems as they come up.
Now, to be fair, the authors are really upfront about the limitations here. This was a pretty small test, only 6 days long. To really prove this concept, you'd need to scale it way, way up. More users, more tasks, and run it for a much longer time. But still, as a first step, these results are incredibly exciting.
And that leaves us with this really fascinating question to think about. SkillClaw gives us a peek into a future where our AI tools aren't just these static programs. Instead, they're part of this living, breathing ecosystem that's constantly learning and evolving from the collective wisdom of every single user. What could we build with a system like that? It's an amazing thought.